All right, so we'll get going. If anybody else jumps in, not a big deal. We'll just let them jump in as we're rolling along here. So, thanks everyone for hopping on and joining us this late morning, early afternoon here. So today we will be discussing the topic of grab sampling and some of the best practices and some of the ways to achieve some of the goals there that align with not only Swagelok's offerings, but some of the industry standards out there to keep everyone safe and uh, keep everyone working and collecting great samples every day in and out. So, just for a little bit of the housekeeping stuff, I'll run through. I have a PowerPoint queued up, so I'll run through kind of what I have prepared, some of the industry best practices, a little bit on the back end of some cool animations and stuff of how the panels actually function and work. So that'll go about 30, 45 minutes, whatever the case may be. If you could during that, we'll just keep microphones muted. If you have a question during that, you can go ahead and type it into the chat. That's not a problem at all. But on the back end of that, we will open up the microphones if you want to pop in. And if you have any questions, comments, concerns, would like to see anything else afterwards, not a problem at all. And if you are more comfortable with that chat function, you could still utilize that as well. So that's kind of the format of how we'll run through this presentation. A little bit on me. That's my photo right there. I'll be your presenter. I'm Gary Osman. So I've been with Swagelok Pittsburgh for about 9 years now, mostly in the capacity of an applications engineer. Last year I joined the Swagelok Global Field Engineering team as well. So that's a little bit of an additional or expansion of my role, which has really benefited myself and our distributor up until this point. So a little bit background on that program. The Swagelok Field Engineering program is a global network of people in similar roles to myself throughout Swagelok distributors across the globe. So there's currently about 140 field engineers worldwide, and as you would expect, there's different specializations and expertise throughout that group. So it really helps you network and connect with people that have similar industries and similar markets. One sec. Let me just see if I can add this. There we go. We're good. Sorry. And so a big part of that team is like collaboration, sharing of solutions that people are seeing at customers in their specific area with other customers across the globe. So it really helps utilize knowledge and power of knowledge sharing to help people in their specific geographical territory. A lot of the team has developed is going out and doing fluid power evaluation and audits. So we've done over 100 plus evaluations just in 2020. So going out and evaluating from source to point of use for various gases, fluids, liquids, processes, and documenting it and putting a report together to help the end user. So that's just a little bit about the field engineering team. And here's a brief map of where the field engineers are located currently, and that's ever expanding every year. There's another 20 or so that are being added to the team. So it continues to grow, add, and become a powerful tool for not only us here, but all of our customers, you guys. So it's a good benefit, it's added benefit for us. So in terms of grab sampling for this webinar, we're going to start kind of at the base level of what is grab sampling, what, when, why. Let's define the term. What is it? What are we trying to achieve? We'll compare it a little bit with, I guess, the other very popular way of sampling, online analytical sampling, which those are kind of the two main methods. So we'll compare the pros and cons of grab sampling versus the online analytical method. We'll talk about some of the goals you're trying to achieve when you grab sample, two of the big ones there being safe and representative sampling, and some of the design considerations that you can think about in your specific panel or process to help achieve those goals. We'll hit on some of the best practices there towards the back end of things, again, you can design into your panel that will help you have a great sampling experience from beginning to end. We'll review some of that stuff and then run through a couple slides there of some of the Swagelok modules and how our designs, and there's probably some other out there that help you achieve those goals. So we have a little P&ID and some module information on our stuff that we'll hit on the back end. So what is grab sampling? It's a pretty intuitive word. It's it's the physical collection of a process media, albeit liquid, gas, or somewhere in between, and collecting that into some sort of container from your process pipeline storage vessel and transporting it for analysis. So wherever the lab or the analyzer is that it needs to be analyzed at, it needs to go there physically. So it's the capture and the transport of that sample for analysis. Some of the other names there that it's typically called laboratory sampling or field or spot sampling, it's all interchangeable. And there's a lot of different ways and styles and methods of doing it. Typically in the industry, it's kind of broken down into the two categories you see here. The cylinder samplers, which are defined by the vessel that the cylinder is being captured in. It would be a metal, single cavity, typically cylinder that you see there, and that can be utilized for liquids or gases under pressure typically. So any pressurized vapor or liquid would be collected into that style vessel. And there on the right, you see bottle samplers, and that's more typically a glass Boston round style or some sort of plastic or any other type of polymer bottle that your facility would be utilizing can utilize that method. And that's more for atmospheric collection of samples. So a liquid that is not under pressure typically goes into a sampler of that style. So in your process, where would you typically utilize grab sampling or see it most commonly utilized? These are just some of the high-level areas in a process. Bulk transport and storage, so that stuff before it comes into your facility, you want to know what's in there. Grab sampling is a great way to take a capture of that and analyze it. Throughout your process, any changes or any fractionation or cryo you're doing to your bulk storage stuff coming in, you want to see where it's at and what the makeup is throughout your process. And then also, typically you'll have on-site storage, so you want to maybe grab sample it prior to going into there or prior to coming out of there. So what's in there and what's being moved to the end user or where you're transporting it to. So those are a couple of the areas that you would want to grab a sample. And why are you doing it? A lot of it is you want to know what your process conditions is and if you are meeting the specifications required. A lot of the times it suits up with analyzer sampling as well. You want to be as close to that spec as possible, so you're not overselling your product, I guess, in a lot of industries. And when online analyzer sampling is used, this is also, it's not eradicating the use of grab sampling. Grab sampling is still relevant and a lot of times required because it needs to validate your online analyzer. So you can have a secondary readout to ensure that your first method of sampling is accurate and performing as it should. And a lot of times custody chains and change over to different customers, loading platforms and whatnot, a grab sample is required. And also it ties into a lot of emissions, EPA or emission monitoring, pull a sample to see what type of emissions are coming off of your process. Some of the locations, again, within your process, we kind of hit on that before, but any of your bulk storage or storage on site would be a good area to take a sample and know what's in your vessels there. Any long transport line, how to change it from point A to point B, or just a good area to grab it while it's transferring throughout your process lines. And if you have analyzers already set up, like I said, as a redundant check of those, that's a pretty easy location to be able to tap into an existing inlet, outlet, or flow to your analyzer and pull a physical grab sample as well as a redundant check. So that would be a good area to entertain doing some grab sampling. So we'll run through a little bit of, I've talked about it a bunch more. These are kind of the two main categories of sampling, I guess you could call it. The online analyzer sampling, which, is typically more frequent sampling. You a lot of times see a sample pull off of your line maybe every 10 minutes, 15 minutes. It's a more frequent sampling to give you a more up-to-date reality dose of how your process is affecting your product. So that's more of the analyzer thing. It's remote monitoring a lot of the times. It's automated, where grab sampling is more of the physical, usually happens less frequently, redundancy checks of your online sampling a lot of the time. So some of the pros here of grab sampling is it's less expensive for sure. I mean, any analyzer or gas chromatograph, you're talking high dollars, very expensive to not only purchase, but to install and to maintain. Grab sampling is typically just mechanical components, pretty simplistic. A lot of the common tubing, ball valves, check valves, stuff like that you're common with when you hear you're familiar with when you hear Swagelok. It utilizes all those products. So it's not a very expensive process to install and utilize it from nothing to fully functional. And like I said, easy to maintain. It uses all standard mechanical products that have maintenance package. You can change seals, you can change items pretty quickly in and out. So the maintenance on it is not overwhelming. It can be installed almost anywhere the panel can fit, which is nice too. So anywhere you can pull a tap off or fit a panel, you can put a grab sample panel in it and pull your sample from in your facility. So it's pretty flexible and versatile in that manner. And typically, if you have a lab on site or if you're sending it down the road to a lab or whatever, the lab technicians are overseeing a lot of this process. So your expertise of gathering and collecting the sample, transporting to the lab to be analyzed can kind of be concentrated under one roof. So they're controlling a lot of the aspects and taking a lot of the variables out of the equation. Some of the cons is time delay. It takes longer. So, and it's designed that way. So time delay is much more critical for online analyzer sampling. Dealing with much smaller volumes, you want to get that sample to the analyzer as quickly as possible to give you an accurate reading of what's in your process. We know with grab sampling, it's going to take minutes, hours, days sometimes, and you just design for that. So you are accounting for that when you're putting a system in and pulling a sample and running it to your analyzer in the lab. You know it's going to take longer. The downside is it just takes longer. So if you have an error in your process or your product's out of spec, you're not going to catch it with a grab sample within minutes typically. It takes a little bit longer. And with that, second point is, it typically has some rough transit time. Sometimes it's in the back of a truck rolling around for a while in the sample bottle until, days, hours, temperature change, until it gets to the lab. So you do have to try to plan for a transit time as best you can, and we'll hit a little bit on some best practices for that on the back end here. But that's I guess you could look at as a con. The dangerous side is definitely there. Like I said, it's in the operator's basket to really handle this sampling. So typically, if they don't have a grab sample panel, the operator's holding this pressurized cylinder when they actuate valves and pull a sample out of process. We make it a little safer, and that's what we strive for by taking the bottle out of the operator's hand, but they are still within earshot of the panel as they're actuating valves. So there is more human interaction to the sample extraction from process. So that does potentially make it more dangerous. And the purity in representative sample collection could be an issue if you're not properly maintaining your stream of sample bottles, purging them, cleaning them down before you put them back into the panel system, because that contamination can just flush through and ultimately affect your readouts when you take the next sample to the lab. So one of the main goals and benefits and features and advantages that you want to design for, and why you want to implement grab sample panels and grab sampling is the safety, right? So that was kind of what we hit on, of getting that cylinder out of the operator's hand as best you can. So you want to reduce the operator's exposure to that. You don't want any admissions of your process anywhere near the grab sample panel. We have a lot of designs where it's a continuous flow. You can return the inlet to outlet. There's no accidental escape or planned escape of process anywhere near the sample location. So that minimizes operators' exposure to process. You're taking the bottle out of their hand. You're simplifying operation. So we have standard designs for all these panels. So the same exact panel is installed at every location, comes with the same exact operating instructions. So operator A can take the same exact sample in the same manner at location 1 through 10, and there's no variation. So being able to train your team on the proper manner of obtaining a sample that is identical throughout your facility is a huge advantage. So it really minimizes user error almost as much as possible. So these are some key design features of a panel and making them standard and uniform. And being able to implement a purge gas or liquid into your process, so something inert, safe, that you're able to plumb and inject into your system, your panel pretty much, helps minimize exposure for the operator as well. So if you're able to put a nitrogen or an argon or something up to your panel, after you pull your sample, collect it, isolate your sample cylinder, you can flush the entire wetted system with a safe inert gas or liquid, whatever the case may be. And at the time the operator needs to disconnect the cylinder from the panel, there is no entrapped gas or spillage of liquid in that small volume between the quick connects. It's just an additional safety measure. So a safety purge is a design consideration that you can have when thinking about these as well. So we have a little 2-minute video here that it's a nice animation. I definitely want to show it to you guys. And it's going to run through a standard gas panel that has a purge function built into it. So it'll show you nice arrows and it has background music, so I won't talk, so you can just read and follow through, but it goes through the full process of, plugging the cylinder in, letting the sample flush through, collecting it, now letting it vent, and then purging through the panel. And it's different colors for everything. It's a pretty cool video. So we'll run through this for 2 minutes quickly here and get back on after. So there was a cool animation kind of showing you the general function of that specific panel. And again, there's other options and you could put a continuous flow into it, but that was just that specific one with the addition of the purge. So that's a nice animation to kind of demonstrate the functionality of it. So on top of all the safety considerations, which is typically number one in most people's minds, you want to ultimately, what are you trying to do? You're trying to validate what's in your process. So you don't want to take something that's going to give you an improper readout of what's in there. So getting a representative sample is the next goal, really. You want to get something that is 100% what is in your process at that time of collection. So avoiding contamination is huge. Trying to keep all your cylinders as clean as possible, purged out, purging out your process as much as possible, your panel when you're done with it, and introducing flush times a lot of the time so you don't have deadheads to your panel if it was a standard flow. These are all design considerations that you could utilize to help make sure that that's a representative sample. And response time is important. I mean, that's not as important as online analyzers, like we said, but you want to know what that's going to be. I mean, are your guys going to be collecting it from the facility or process and transporting it within an hour, or is it going to be more a 4-hour to 8-hour time? Whatever it is, you want to know. So if you need to add some sort of heated cylinder to keep the temperature where it needs to be, or any temperature pressure changes that it's going to encounter during that transit time till it's analyzed, needs to be accounted for and designed for. And a lot of that is just to this, temperature change is big. So whenever you're sampling any gas or liquid that is near a phase change, so anything that's close to a dew point, a gas that's going to start bubbling or liquefying, or a liquid that's going to start bubbling off or turning into a vapor within your bottle, you have to make sure it doesn't get to that point, unless you intend for it. Now, if you intend for it, you could actually vaporize prior to putting it in the bottle, or if it's going to do a little bit and it doesn't hurt your analyzer, great. But you do have to be aware of that and try to either minimize it or eliminate it if you don't want it, or just make sure that you know what's happening in that bottle before it's run through the analyzer. So back to the selection. So if you remember back in the first slide or so, it breaks down into two categories: the glass or plastic liquid collection bottle, or a stainless steel or different metal cylinder. So how do you select one? And really, we say, and ASTM there, the code listed there says this as well. Anything above atmosphere should really go into the stainless steel single cavity collection vessel. Anything below or anything below that or atmosphere liquids can go into the glass bottle. So that's typically how we recommend it and how we would say it, and that's ASTM says a similar thing. So some of the design considerations. The panel video that we saw before has the standard flow. So it's just going to be deadheaded to that panel. When you open to sample, it's going to flush through all the wetted lines in your sample vessel on the panel. An option we do have is continuous flow. And what that is it has an inlet and outlet that is continuously flowing through your panel. So it's like a mini fast loop, essentially. And really what that does is it helps minimize flush time, because now you have a steady, constant flow of fresh process to your panel. So you don't have to clean out a bunch of deadhead or stagnant line. If you did have a viscous sample, it would prevent that from solidifying in the smaller sampling lines of the panel. In that calculation there, it can help you determine what flush time you'd have if you did have a deadheaded panel. A lot of it's based on the internal volume of all the static lines leading up to the sampling area. So sometimes that can get pretty high, depending on how far the lines are to the panel and how big some of the vessels or filters or mixing volumes are that it encounters along the way. So to reduce, just flushing times, designing in a continuous flow could be very advantageous. And a purge fluid, which we saw in the video, can be an option to any of the panels if it makes sense to you or you have the option for it. It's always a good idea, but it's not always required. Some of the best practices when you're doing sample collection, you would always want your cylinder in the vertical orientation, and that's regardless of gas or liquid. Now, the difference of that is when you do have a liquid, you'll be filling from the bottom to the top of the cylinder. Now, what that does is it ensures that you're going to get the volume of sample that you're intending. If you did it in the reverse orientation, potentially you could be flowing out of the cylinder faster than you're filling, and you'd never meet to the volume level that you intend. So you want to fill from the bottom up to ensure that you're getting a full cylinder sample that you're intending. And you would incorporate an outage tube a lot of the times to help keep a vapor space in that liquid sample bottle. So if it does encounter some temperature change during transit, it allows for some some expansion without a huge increase in pressure. So you can design in a vapor space with an outage tube of any percentage outage that you would intend or need to for your process. And then a gas, just vice versa, fills from the top down. And what that allows it to do for your sample collection is have a bunch of any liquid or any condensation or anything that could be in your gas sample is going to naturally drop out due to gravity. And that goes for any like contamination as well. It should hopefully funnel out through the cylinder rather than just blow up into your cylinder bottle and be trapped in there. So that's the difference in the sampling collection method in the orientation, top down or bottom. Our bottle sampler uses an MBS sampling valve, which you can see the double needle system there. So one of them's a fill needle and one of them's a vent, and they come in different sizes, diameters, lengths, whatever you would need based on the bottle and your process. But it uses typically a shroud system there that the sampler will actually, it's an anti-coring needle system, so you can actually reuse the septum on the bottle a few times, but it does create a nice environmental seal and barrier of your liquid in the bottle from environment. So it's another safety mechanism. It prevents accidental spilling during transit or after collection, and it also helps the integrity of your sample by creating that barrier. One other nice safety feature and advantage we have with some of our panels is we offer a fixed volume sampler. What that does is it's meant for liquid samplers, and it actually has a designed-in sample cylinder into the back of the panel, which fills to the volume that you intend. So you always try to fill a little less than your sample collection bottle, and as you go through the normal process and fill the cylinder in the back of your panel, you would have an additional step of putting the purge fluid or gas through your panel to push that sample cylinder volume in the back into your bottle collection on the front. So that would eliminate the error for ever overfilling the bottle and having any spill onto your uh, collection vessel. So a little bit of the review there. This is kind of the stuff that we just hit on already for like best practices and what is grab sampling. I think we pretty good coverage on most of that. I think if anybody has any questions, we'll hit on them in the back end a little bit. But I'll just roll right into some of the standard designs that are offered for grab sampling. So what you see here and what you saw in the video earlier was a GSM module, we call that. So that's simply just the stainless steel cylinder collection method, and we offer about 8 standard designs of these currently. 4 for gas, 4 for liquid. They're just mirrored based on the way that it should flow through the panel, top down or bottom up. And there's some different options and design considerations that we hit a little bit on earlier. Our pretty much the centerpiece of this panel, and I'll show you a cutaway of it next, is the geared valve assembly. And that really helps with the operation of the panel. It simplifies it. It actuates either 2 or 3 three-way valves in tandem. So it helps prevent operator accidentally releasing sample to environment or putting purge gas back into process or anything along those lines. So the safety and operation is really optimized using a valve assembly like this. The standard designs that we talked about can be bought by one part number throughout the globe, and same exact panel would be installed at every location at your facility or any of your facilities around the globe. So the standardization is a huge design feature and benefit of this program and of these panels as well. And as we hit on, the purge option is a great, if you can use it on your system, you should. It's a great advantage all around. So here's a, I guess, CAD view and a real life view of what that geared valve assembly looks like. And it just uses one lockable handle to actuate that from close to sample to vent to help operate the function or help function and operate the panel. So that's the key and the centerpiece of this thing. So it's really nice, really nice feature. And these are just some of the standards when you're going through it. And you get to pretty much select whatever you want and you don't want, what's going to work for you for the application that you're looking for. And these are just, in the back of your mind, these are just a starting point. So all of these are fully customizable from a minimal, changing a quick connect style or keying a quick connect if you wanted, to adding multiple strings per panel or completely revamping the layout or the function of it. So we can make many, minor changes as needed or design a completely different panel for you to meet your needs. So these are the GSCs. These are the cylinder assemblies that would be utilized with the GSM panel that we just saw, and they have much of the same design standards and selection that we saw in the previous slide there. You would see here one without the purge is on the left side there. It would simply flush through your quick connected cylinder assembly. If you did have a panel designed with purge, you would also want to select the cylinder that has this purge bypass loop on the right side you see. So that allows your purge gas to fully sweep your wetted lines on your panel without disturbing the sample which is collected between your valves there in the cylinders. And now we'll run through this is the liquid style assembly. So again, you would be doing atmospheric collection of a liquid using a panel of the style. There's 7 different flow paths. We can, a cooler could be incorporated to help keep your process temperature at a different temperature that you want. Cool it down before putting it in the bottle and carrying it. Any style bottle you really want, we have standards of that, but we can modify as needed. And again, this is the key to that panel. So this is the MBS Sampler. It utilizes a dead man handle on the valve there, which we'll show you in the next animation. But it's a safe. It uses that double needle septum style bottle collection, which we hit on, has that environmental seal. It has a shroud system, so it helps guide the bottle up into the double needle system, and has a rest bar, so again takes it out of the operator's hand while collecting. So there's some nice safety features to that as well. So I picked one out of here. This is going to be a continuous flow panel design, which also has the purge option. So it kind of has the fast loop built into it. And I'll show you in the next slide a little animation of what that looks like and some of the benefits of that. But the purge, again, is added to keep everything clean and make sure you're getting a representative sample each and every time. So what you see here is The valve in the upper left corner there, that's our sample valve. So that's going to be the main valve that you're actuating to control the function of the panel. Down below that is going to be that spring-loaded deadman handle that's on the MBS sampler. So your sample bottle is inserted into the shroud below that, and that's ultimately controlling when the sample can flow through your sample vessel. And on the right half of your screen here is going to be an interactive P&ID here that will have some bubbles flowing through to show you how it operates as you sequence valves. So as you're in the off position here, you'll see the green dots are going to be your process medium. And this has the continuous flow option. So at all times, you have a flow flowing through inlet to outlet of your panel. So that helps eliminate any static legs or contamination buildup because it is a mini fast built into your panel. So you have fresh process plumbed directly into the inlet of your panel, directly into the three-way valve, the inlet of that. So that's an option that is incorporated into this panel. Then you have your inert purge gas, which is blue dots, being plumbed through a regulator, flow meter, needle valve, and check valve to the same three-way valve. Now, everything's off at this position, so nothing is flowing to your sample vessel or the MBS sampler below it. As you actuate your sample valve to sample, which you'd want to be collecting process, you would then depress the blue valve handle there below it on the MBS sampler, which would allow your fresh process to flow through and fill your sample bottle to whatever level you intend. And as you would reach that level, you would just let go. So now you're deadheaded to the MBS sampler of process. And you would rotate your sample valve to the purge. What that's going to do is allow your inert purge gas to flow down through the three-way valve, and now it's at your MBS sampler, which you would depress for whatever duration of time that is suitable for your needs, and that would flush any process out and up through your vent needle on your MBS sampler. So now your system is completely purged clean. You have a fresh representative sample with the correct volume in your cylinder, in your bottle there, part of the panel, and you're able to remove the sample as intended. And that kind of wraps up the prepared presentation we had. So at this point, we're almost on time here for what we were intending. So that's kind of what we had prepared. So we can open up any questions. If you want to unmute and ask a question, feel free to. If you want to type something into the chat function, we can address them in that manner too. If anybody has anything that they would want to chime in with, feel free to.
One question, Gary.
Yep.
We typically, when we get grab samples, we usually get propylene. So propylene, as you probably know, wants to be a vapor. You know, unless you compress it, you know, about over 150. But when we do grab samples, the most concerning thing to us is safety, because it's you really have to be careful that you purge properly. You lots of times with grab samples, you have a disconnect, you know, you're using. So, and I've had a bad experience with grab samples in the past, but it was I had done it many times, and it was one time that I forgot to vent, and I left the valve open, and you addressed some of those things, but for me the biggest thing about grab samples is the safety aspect of it, and we continue to take propylene samples, but I see in your video, I think a better way would do that would be in process, you know, because when we get our propylene from another plant and we pump it into a main tank. So I think a better way to do that would be, you talked about inline process, you know, grabbing the sample inline, which I think would be better for us, you know, to do that while we're pumping the propylene into the vessel, the main vessel. So that's kind of my concern and my question.
Yeah, I mean, that's a very common area to grab a sample while it's in process. For keeping, you know, I think the first part of your question was keeping propylene in a liquid phase and not letting it turn to a vapor. So there's some options for that as well. I mean, you can incorporate like a constant pressure piston style cylinder into these panels as well, which would keep a vapor pressure on the liquid sample within the collection vessel. Those are utilized pretty commonly, and they are almost interchangeable with these panels. There's designs already out there to help with those. So that would be maybe something you'd want to consider to help with the representative sample portion of the question. The safety side of it, I mean, it would be, you can incorporate as much or as little as the options that we showed that would suit where you're collecting it from. So putting it with a purge would be great to help with safety when you disconnect the sample cylinder. I don't know if you have any of those design considerations if you're utilizing those currently.
Yeah, we could talk about some of that, but
yeah, that's something we could absolutely talk offline. How big of a, just sidebar, how big of a collection vessel are you using currently?
I think 150 milliliters is one that we use for collecting, and it doesn't have to be. We're using analyzing with a gas chromatograph, so we typically don't have to keep it in liquid phase. We can have it in gas phase, so it's not a problem like that.
Okay. Yeah, so maybe just designing enough vapor space in there to account for any phase change in the cylinder would help with overpressurization.
That's a good point.
Yep. Yeah, so we could talk a little bit more after this and talk about your specific application. No problem.
We've also sampled solid material pellets, like if you think of a BB, that may be size of sample, and it also has propylene in it, so in that phase we want gas phase, we'll go on solid pellets in the cylinder. Mm-hmm. We've done that in the past also.
Okay.
And that's all the comments I had, but I enjoyed your presentation.
Thanks. Yeah, thanks. And like I said, we can catch up a little bit offline here and talk about your specific application.
Okay, thank you.
Yep, no problem. If anybody else has anything, feel free to chime in. I don't see any questions in here in the chat. But yeah, overall, I mean, it's a very versatile product in terms of the offerings, and we typically just kind of use the standard designs as the starting point for these presentations, much of what you saw today. So all of this is completely customizable, making things bigger, smaller, more streams on a panel, larger cylinders, whatever the case may be. We can make it fit what you need is the key of the customization. So you're not limited to the options that are in the application guide or what you saw today. But yeah, so I think that's all I had for sure. And if there's no other questions, I won't keep everybody on the call much longer than we have to. So I appreciate everyone attending. I hope everyone picked up a nugget or two of something throughout this, and hopefully can utilize some of these practices at their own facilities and processes. But with that said, yeah, I guess we'll wrap it up, and I appreciate everyone popping on and taking a little bit of their day to join our call. And that's about it. Have a good rest of your day, guys.
Thanks, Gary. Thanks, everybody.
Thank you, Gary.
Thank you. I'll definitely look at the recording.
Yeah, we'll send recording out to everybody who's on here, and you can distribute it as you feel fit.
Absolutely. Thank you.